Okay, everybody, we are starting on 6.2, our trig identity unit. These are the identities we're going to be working with. Most of these should be fairly established last unit. We have our reciprocal identities where cosecant's 1 over sine, secant 1 over cosine, cotangent 1 over tangent. Remember, these are the CS pairs as far as the families go. Tangent, we know at this point, is sine theta over cosine theta. Cotangent is the reciprocal of that, cosine over sine. For our Pythagorean theorems, you must know these. We talked about them again in the last unit. Keep in mind, we can also use alternate forms of these. So we can subtract cosine squared theta, or we could subtract sine squared theta over to the other side. This identity here has been established by taking sine squared theta plus cosine squared theta equals 1 and dividing everything through by cosine theta, getting cosine squared theta, So sine squared over cosine squared would get you tangent. Cosine over cosine gets us 1. 1 over cosine squared would get us secant squared theta. This one over here was taking your basic, again, Pythagorean identity of cosine squared theta, sine squared theta equals 1. And this time we are dividing by sine squared theta. These, again, reducing to get us 1. Cosine over sine would get you cotangent. 1 over sine squared theta would get us cosecant squared theta. Our even odd identities, again, I want you to kind of think about as you're moving from quadrant number 1, if theta's here, to quadrant number 4, having a same reference angle of theta. If the sign changes from quadrant 1 to 4, then the negative gets pulled to the outside. So for the sine family, y is positive in 1, negative in 4, so the negative gets pulled to the outside. For the cosine family, as we move from quadrant 1 to 4, the x stays positive, so I'm just calling it like the negative gets absorbed. Tangent also, as you move from 1 to 4, we have a sign change, so again, for the tangent family, that negative will be pulled to the outside. This is going to be a little bit of a rough lesson because there's no algorithm here. You're just going to have to follow some simple rules and just give these a try. We're going to work on one side of the equation at a time. We're going to look for things like being able to factor. I'm going to use those fundamental trig identities that I just spoke of. We may have to rationalize denominators. We're going to use the conjugate there. I would consider number 5 and 6 probably my first go-tos. Try converting everything to sines and cosines at first. But most importantly, do not just sit and stare at the problem. You need to try and write something. All right, so for these first ones, we're going to just start with the simplifying of the identities here. These are actually a little bit more tricky than when we have set equals. You don't really know where to stop. So we're going to just kind of go through these. I'm going to look at tan theta, and I say to myself, all right, so tan is sine theta over cosine theta, and secant's really 1 over cosine theta. Since both of these are in the denominator, we can cancel these out because if we multiplied by cosine theta over cosine theta, they would cancel out, and what we're left here is sine theta. If you get yourself to a single trig function, you pretty much are done with the problem. All right, so let's try the next one. We're looking at cotangent theta over cosecant theta. So my first go-to really is to change everything to sines and cosines. So cotangent is the same as cosine theta over sine theta. Cosecant is 1 over sine theta. And as before, since both of these are sitting in the denominators, they can cancel out. And that would simplify to simply cosine theta. We're at a single trig function. And so we're able to stop. Okay, So looking at 3, first I'm noticing this 1 minus cosine squared x. Anytime you see a squared, you're looking at those Pythagorean identities. This is the sine squared theta plus cosine squared theta equal 1, where we're subtracting the cosine squared theta to the other side. So this can be replaced with sine squared theta. Cosecant is 1 over sine theta. So now I have 2 sines in the numerator, 1 sine in the denominator. One of them will cancel out, and we're going to reduce ourselves to sine theta. I do need to stress to you guys that the value in all this is the work, so there is no skipping of steps. You will have to write everything out as we go. Alright, so let's look at number 4 here. First I see all those negatives, so let's think to ourselves what's going to happen here. So normally for sine the negative would get moved to the outside, but it is being squared. So this is just going to become sine squared theta. Cosine it would get absorbed, and then even if not being squared, that would also become positive. For the denominator, the negative will be pulled to the outside, and for cosine it's going to be absorbed. So if I see the negative odd even features, that's what I take care of first. So I'm looking at this, I see squares, so I'm thinking it's somewhere in my Pythagorean identities maybe, but that should have been a plus if it was the identity, and it's not. This is factorable though. It is going to factor into sine theta plus cosine theta, sine theta minus cosine theta. And on the bottom I could factor out a negative from these guys here. These are the same in both the numerator and the denominator, so we're able to cross these out, and that's going to leave us with minus sine theta plus cosine theta. It's fine like that. I don't really like the negative lead, so I'm just going to switch it around. I would accept both of these answers as being correct though. Alright, let's flip our papers over and continue. What are we looking at here? So I see some squares. This kind of got me thinking in the Pythagorean family here. It is very important here that you never divide by a trig function. You always must factor things out. So I see that they both share a tan squared x. So I'm going to take tan squared x out, leaving me with 1 minus sine squared x. Okay, well 1 minus sine squared x is that basic Pythagorean identity with the sine squared subtracted to the other side. So this is going to get me tan squared x times cosine squared x. But tangent is really sine over cosine times cosine squared x. The cosines will cancel, and we will be left with sine squared x. Again, the value in this is showing all the work. If you just write sine squared x, no credit will be awarded to you guys. Alright, so let's take a look at number 6. First, let's just kind of take care of that negative. So let's pull that out to the outside. And I'm looking at this and I'm kind of stuck. So what I'm going to do is multiply the denominator by a conjugate, and that's going to get me into those Pythagorean identities. So I'm going to multiply both numerator and denominator by the conjugate. Alright, so for the denominator here, we're going to get 1 minus cosine squared theta. When we multiply by a conjugate, the O and the I of the FOIL will drop. And I'm going to leave, I think, this one just as it is. I'm not going to distribute it at this time. I want to see what I get. So I know 1 minus cosine squared theta is the same thing as sine squared theta. So I can definitely, at this point, go ahead and eliminate one of these. So I'm just going to move this over to the side here. So now I'm going to have minus 1 plus cosine theta over just sine theta. I guess you could have distributed at this point. So minus 1 minus cosine theta over sine theta. If you're over just one trig function, you can separate out the fractions. So we're going to have minus 1 over sine theta minus cosine theta over sine theta. And this guy is going to reduce to negative cosecant theta minus cotangent theta. You could also, if you want to take this answer, you could also factor out that negative cosecant theta plus cotangent theta. That was a tough one as far as simplifying goes because you don't really know where to stop, but that's as far as we can get on that one. All right, let's look at problem number 7 here. Sine squared theta minus 1. So that's not the Pythagorean one with it just kind of simplified over there. Let's just try a couple of things. That is factorable. So I'm going to go ahead and factor that out. There are more than one way to do these, but I'm just going to kind of see what I see first. So sine theta plus 1, sine theta minus 1. On the bottom, I'm going to factor out a tan theta. It's common to both terms. So what I notice at this point here are those two cancel out. They're the same in the numerator and denominator. At this point, this is over the same trig function there. So I'm going to separate them out. Yeah. Okay, 1 over tan theta. What I'm going to get here, this is really going to be sine theta over sine theta over cosine theta plus 1 over tangent would be cotangent theta. If you think about this as a keep, change, flip situation here, I could say sine theta times cosine theta over sine theta. That's what a fraction really means to do. You're dividing, so you keep, change, flip. The signs cancel out, so we're going to wind up with cosine theta plus cotangent theta. So let's kind of move down a little bit here. I like these problems a little bit better because we know where we need to stop. So we're actually giving you the answer, so to speak. Again, remember this is all about the work, and you may only work one side of the equation at a time. So I know that I need to bring this guy into secant theta. What I'm going to do first is just distribute everything. So that's going to say sine theta times cotangent theta plus sine theta times tan theta. One of my first go-to things is to turn everything into sines and cosines. So I have sine theta times cosine theta over sine theta plus sine theta times sine theta over cosine theta. So on this side here, the signs will cancel. I'm just going to be left with cosine theta. On this one here, I'm going to multiply these together, and we're going to get sine squared theta over cosine theta. Now, in order to add, I need to get to one term, so eventually I'm going to have to add these guys together. So in order to add, you're going to have to get a common denominator. So I'm going to multiply each step or the first term, by cosine theta over cosine theta. Now I have cosine squared theta plus sine squared theta all over cosine theta because I've established that common denominator. Cosine squared theta plus sine squared theta is really 1 over cosine theta, which will reduce to secant theta. Again, there may be other approaches to this. You can do anything you want so long as you're not making up your own rules here. But you do need to work one side. You do need to show all the steps as we go through. All right, so let's take a look at number 9. I'm looking at this. I'm not really sure where I want to go with this. So I'm going to just first change everything into sines and cosines. That's usually my first go-to step. So cosecant's really 1 over sine theta. Cotangent is cosine theta over sine theta. Since they do have a common denominator, we can go ahead and write that as one term over that common denominator. I'm not quite at the place I want to be. I do notice I need to get this 1 plus cosine theta into the denominator, which is the conjugate to 1 minus cosine theta. So I'm going to give that a try. I'm going to multiply both top and bottom by 1 plus cosine theta, because that's going to get that into the denominator to me. Since these are conjugates, we're going to wind up with 1 minus cosine squared theta over sine theta times 1 plus cosine theta. It's looking closer to what I need. This is the basic Pythagorean identity with the cosine subtracted over to the other side. So this is going to be the same as sine squared theta over sine theta plus 1 cosine theta. One of the sines will cancel, and eventually we will get to where we need to be, which is sine theta over 1 plus cosine theta. So again, all steps must be written out. You're going to be rewriting things a few times, but that is okay. Let's go down to number 10 here on your paper. So I'm looking at this, and I want to say to myself, I need to get this to look like a 1 plus sine theta. Again, I say to myself, that is the conjugate of 1 minus sine theta. So I'm going to multiply both the top and the bottom by 1 plus sine theta. In the numerator, I will get myself 1 minus sine squared theta over 1 plus sine theta times cosine theta. I purposely didn't distribute this at this time because this is what I'm looking for in the denominator over here. 1 minus sine squared theta is cosine squared theta. So I'm showing that replacement there. Again, not skipping any steps. Now I can cancel out one of the cosine thetas from the numerator and denominator, and I'm left with cosine theta over 1 plus sine theta. Okay, good. We're looking at number 11. It looks kind of complicated, but I think if we just take it one step at a time, we should be fine. This is a difference of 2 perfect cubes. That's that SOAP factoring. So this is going to factor into sine theta minus cosine theta, sine squared theta, plus sine theta cosine theta, plus cosine squared theta. So, same, opposite, always positive. That's just a factoring that you're going to need to have committed to your memory. All this is going to be over sine theta minus cosine theta. These guys cancel out, and lo and behold, we are left with what our identity wanted to be, which you will rewrite. And actually turned out to be a fairly simple one. I have one last challenge problem here. We are just letting you guys know that these things can be factored. So we're going to take a look at this guy here. So I want this to turn into the one on the right. This is factorable. So I am looking at 2 sine x times sine x plus 1. On the bottom there, this is going to be factored into sine x plus 1, sine x plus 1. One of them do cancel out just like that, and we are then left with what is established on the right. So 2 sine x plus 1 over sine x plus 1. All right, so that's it for today's lesson. We will have a 6.2a where we will continue practicing with these where the identities get a little bit more complicated. I will see you all next time.